Hello everyone, welcome to my YouTube channel. Like yesterday I have uploaded one video on the first chapter of class 9 chemistry, that is atoms and molecules. As I said, that mole is an important concept of this chapter where children face most of the difficulty. Just understanding the definition is not appropriate. It is very important to have the practice of the questions also. So today we'll be doing the practice questions on the mole concept. Okay, so let us have a look, once again revise the mole concept, and based on that we'll be doing the questions. So here children, these are the three formulas which we discussed yesterday. Okay, for solving the mole concept, these are the three main important formulas. If you are clear with this formula part, then you will be able to solve any type of the numerical question based at 9th level. So we discussed this, that mole, when it is expressed in terms of number, so it is equal to small n equals to capital N upon n0. This is जब भी हम मोल को in terms of number में express करते हैं. If you want a relationship between moles and the number, so this is the formula, small n equals to capital N upon n0. What is this capital N and n0? I have already mentioned here, number of particles, and n0 is your Avogadro's number whose value is 6.022 into 10 to the power 23. Similarly, in terms of mass, if we want to express mole in terms of mass, then it is equal to small n equals to small m upon capital M, where m is the mass of the given substance which will be given in the question, whereas capital M is your molar mass or the molecular mass. So this is the first very important formula. Second formula, as you can see here, that mole it is equals to n by n0 and small n is also equal to small m by capital M. So simply you can equate both this equation 1 and 2, and as a result you will get this equation number 3, you can say, where correlating this, equating both the equation, you will get capital N upon n0 equals to small m upon capital M. So this is, these three formulas you have to thoroughly revise, remember. If you won't able to revise this, you won't be able to solve the moles question. Okay, now this is just a definition. Two terms are associated when we consider the mole thing. One is your gram atomic mass. You can see in the next slide it is there. One is, whenever this mole it is expressed in mass, there are two things. When you express the amount of a substance in grams of an atom, okay, whenever an atom mass it is expressed in grams, okay, whenever the atom mass it is expressed in grams, it is referred to be as a gram atomic mass. Just let us have a look in this slide, you will understand more clearly. Yeah, so here you can see that gram atomic mass. What is this? Atomic mass of the element expressed in grams, that is your gram atomic mass. Fine. And if you will see, like gram molecular mass, gram molecular mass is whenever the molecular mass it is expressed in grams, that is referred to be as GMM, gram molecular mass, and this is your gram atomic mass. Okay, these two things are very important to be noted to further solve the questions, that what is this gram atomic mass and what is this gram molecular mass. Okay, suppose for example, like let us see gram atomic mass of any particular element. Suppose when I say gram atomic mass of hydrogen, so what it will be equal to? It will be equal to 1 grams. If you will say atomic mass, so it will be 1 U. U stands for unified mass. Okay, so whenever this mass simply it is represented in grams, you will say it to be as a gram atomic mass. Okay, suppose for, if you say atomic mass of oxygen, so what you will write, how you will represent this? You will represent it as 16U. Okay, but when you will say gram atomic mass of oxygen, so that will be equals to 16 grams. That is the difference. Simply when the atomic mass it is represented in terms of grams, it is gram atomic mass. When this atom, suppose if it is replaced by a compound, okay, so in that case what you will use, rather than using the term atomic mass, you will use the term as molecular mass. What will be using? We will be using in terms of molecular mass. Suppose for example H2 is a molecule, right? Here this is an atom, This is a molecule. I hope everyone understands the difference between an atom. Atom is a simplest unit of a matter, whereas when the atoms combine, so the molecules are formed, right? So here if you consider the molecular mass of H2, in this case what you will write when you will say molecular mass of H2? Molecular mass of H2 you will write it as 2U. But when you will say gram molecular mass, so it will be 2 grams. Rather than 2U, you will write it as 2 grams. Simply suppose for oxygen. For oxygen, if you will see the molecular mass, for oxygen the molecular mass is 16U, right? But when you will say gram molecular mass, it will be 16 grams. That is the only difference between the gram atomic mass and gram molecular mass. I hope the thing is clear to everyone. So these are some of the basic things which you should be very clear with these terms, like gram atomic mass, gram molecular mass, then mole, and that Avogadro's number and all this. This is one thing which I will be taking this topic in the next class, like atomicity is there. This one topic has been left from that atom and molecules chapter. While making the video skipped out of my mind, so I will make a separate video on this atomicity thing. Okay, just today in today's lecture we will be just discussing the numericals based on the mole concept. So let us go for the questions. These are the some very basic questions by which you will be, the concept of mole will be clear to all of you. And this set of questions which I have discussed here, only you will find the variations of these questions. The questions will be in different form, but this is a basic, all the variations which are found in the mole concept I have discussed here in this video. Okay, so just go through those, and different variations you will find it in this video. So let us go for this set of questions. Okay, so the first question here is what is a number? So whenever you solve a numerical, make sure that first you write down the given things. Given things, what is given to you in the question and what you are supposed to find out. So here, what is the number? We know that number is represented by capital N. So capital N is a question mark. You need to find out what is given to you in 0.2.5 moles of oxygen. So mole is represented by small n. Okay, all the symbolic representations also it is very important to remember. Small n is equals to 0.25. Okay, now we have small n with us, capital N you have to find out. So you see, whenever the questions are asked, so this is mole, what is the type of the question? Mole in terms of number. Mole in terms of number is given to you, right? And so what is the formula? Mole in terms of number, small n equals to capital N upon N0, right? We have the value of this small n with us. Capital N you have to find out, and N0 we know, it is already known to us that it is 6.022 into 10 to the power 23. So just put the values in this formula. So small n we are putting the value as 0.25. Okay, in this formula I am saying. Capital N you have to find out, and this is 6.022 into 10 to the power 23, which is your Avogadro's number. Right. So capital N will become 0.25 into 6.022 into 10 to the power 23. So which gives you the value of 1.505 into 10 to the power 23. Yes, so this is just a simple question based on the concept, but until and unless you understand the importance of this formula, these simple questions also you will feel like it's a big mountain for you to just solve it. Okay, so this is just one of the variation. Let us go for the second question. Any queries related to the question or the content is there, so definitely give your feedback in the comment section. Now let us go for the second question. So it is about how many, sorry, just a minute. How many electrons, just a minute children. Yeah. How many electrons are present in 1.6 gram of methane? So here how many electrons means number is asked. Number is asked to you, right? Whatever is given you just note down, whatever you need to find out, first clarify that, then only you will be able to solve the question. Okay, what is given to you? Mass is given to you 1.6 grams. Of what? Of methane. Methane, the formula for methane is CH4, right? So what all things we have with us? You have to find out the number. How many electrons means obviously the number of electrons you need to find out, and mass is given to you. Mass is 1.6 gram of methane, right? So how you are supposed to do? We know that we have the relationship of moles in terms of number, and this one you can go with this formula. Can you see here? This one. What all things are given to us? See, check out this formula. This one, है ना? Capital N upon N0 equals to small m upon capital M. Yes, so let us go with this formula. Capital N upon N0 equals to small m upon capital M. Yes, so electrons it is asked, Avogadro number is known to you, mass is known to you, and molecular mass you can find out of methane. See, molecular mass, how you will find out? Mass of carbon atom is 12 plus 4 into mass of hydrogen atom is 1. So it becomes 12 plus 4. It becomes your 16 grams. So can we find out this portion first to make our calculation easier? Just put the values. Mass is given to you 1.6. Molecular mass is, just now we have calculated 16. Okay, so 1.6 upon 16, it will be your 0.1. And what is this mass of a molecular mass? This is nothing but the moles, right? So you can see here that first you need to find out that how many molecules of methane are present in 0.1 mole, right? You need to find out first with reference to 0.1 moles how many molecules of methanes are present. Okay, so first you can go with this. Number of molecules of methane in 0.1 mole. So what you can do? See, I am writing here with this formula, capital N upon N0 equals to, this value you have calculated and it has come up to be as 0.1, right? So if you need to find out the number of molecules of methane, so what you can do? Capital N equals to 0.1 into Avogadro's number. This is just simple. Just try to understand it in simple steps. It will be very easier for you to do. So capital N, we are finding what? The number of molecules of methane in how many moles? 0.1 moles, right? So what it will be equals to? Capital N will be equal to 6.022 into 10 to the power 22, right? This decimal value if you will replace, so 1 upon 10 will come. So it is 6.022 into 10 to the power 22, right? I am just taking the next slide. Yeah, so capital N we have calculated right now, which is equals to 6.022 into 10 to the power 22, right? Now the thing is, if these many molecules, this is what number, no? So these many molecules will have how many electrons? Number of electrons is asked. Okay, so first you need to calculate that if in one atom of CH4 is there, so how many electrons are there? How many electrons are there in this? How we can calculate the electrons? We know that number of electrons is equal to what? Atomic number, right? Number of electrons is equal to the atomic number, or it is also equal to your this one number of protons, right? So for carbon, the number of electrons present in carbon is 6 plus 1 electron is present in hydrogen, but there are 4 hydrogen atoms, so 6 plus 4, so this becomes your 10 electrons. Is this part clear? CH4, first you need to, our question is to find out what? The number of electrons, right? So number of electrons first you will find out with this, but you need to first calculate it that with one molecule of methane how many electrons are associated. जैसे हम बोलते हैं ना कि 1 pen cost is 2 rupees. So what is the cost of 2 pen? So it becomes your 4. So similarly here, if 1 mole of CH4 is there, so how many electrons are there in this one molecule, you can say, because here we are talking in terms of molecule. So one molecule of CH4, it has 10 electrons. How we have calculated this? Via this way. Okay, in this what we have seen, for carbon, the number of electrons associated with the carbon is 6, number of electrons associated with the hydrogen is 4, because there are 4 hydrogen atoms, so 1 into 4 becomes your 4, 6 plus 4 it is 10 electrons. So this is only for one molecule, but you have to tell that how many electrons are present with this 1.6 gram, no? So in this we have calculated the number of molecules. How many number of molecules are there here? 6.022 into 10 to the power 23. So in this many number of molecules, how many electrons are there? X. So what you will do, you will just cross multiply it. So X is equals to 6.022 into 10 to the power 23 into 10. Yes. So what it will be? Sorry, it was supposed to be 22. Just kindly do this correction. It is 22. Yeah, 22. Here also you do the correction. Yes, and now if you will calculate, so it is 6.022 into 10 to the power 23 electrons. Is it clear to everyone? Just kindly check out this. What we have done, let me just revise up the steps. Here first we have calculated. Yeah, here first we have calculated the number of moles, okay, 0.1 moles has come. Then we have calculated the second step, that is the number of molecules of methane in this 0.1, because here the question is asked in terms of number, no? So we need to get the values in terms of number, right? So number of molecules of methane in 0.1 moles will be equal to, here you have calculated 0.1 into this, so you got this many number of molecules, right? And then later we have put this in this formula, like with the concept of unitary method. This is what, how we have solved this, with the help of unitary method. Unitary method, what does, when pen cost is 2 rupees, so 2 pence cost is 4 rupees. Similarly, one molecule of methane, it has 10 electrons, so these many number of molecules of methane will have how many electrons, right? So this is 6.022 into 10 to the power 23 electrons. Am I clear? Let us, so this is the second variety of the mole question which we have done. Let us come to this, the third variety of the question, that you have to calculate here mass. This is also a simple question. You can easily do that with those set of 3 formulas which I said in the very beginning of the video, right? So you need to calculate the mass of, first question let us solve. What is given to us? Given is N value is given, 0.2 mole molecule of oxygen is given, and you have to calculate the mass. Mass is question mark. Again go with the same formula which we discussed, capital N upon, just a minute, yeah, capital N, calculate the mass it is asked, no? So 0.2 mole molecules of oxygen. Now see, there is one confusion which I would like to give the attention here, where most of the students do this mistake. As soon as you see this oxygen atom, what do? You take the mass of oxygen atoms to be a 16 gram, but this is wrong. See this word molecule. See, oxygen means 16 grams. Okay, when we say oxygen molecule, it is O2. Molecule is what? Formed by the combination of 2 atoms, right? So O2 mass, it becomes 32 grams. So the major mistake where the children do in this question is basically with the molecular mass of the component. Okay, so molecular mass of oxygen will be what? Will be 32 U. Okay, so molar mass will become, molar mass or gram molecular mass, if you will take it in terms of grams, so it will become 32 grams, right? Now if 1 mole of oxygen atom is having how many grams? Like 32 grams. So here 0.2 mole molecules of oxygen will have how much? This is also, see here we have this also, we can do with the unitary method. There is no confusion in that. You can do with this set of question also, okay, right? Or you have the formula with you, a formula which is there, small n equals to small m upon capital M. With this formula also you can do, where you need to find out this mass is a question mark, right? So small n is given to you 0.2 moles, then small m you need to find out, and capital M, molar mass of oxygen, that is your 32. So here most of the time children take it as 16, but don't mistake, it will be 32 because O2 molecule is said. Now, so this is the first method. There are two ways which you can do the question. This is the first method with where you have done it with the help of formula. Okay, mole in terms of mass, small n equals to small m upon capital M, and this one is your unitary method again. है ना? Like suppose 1 mole is 32 gram, so 0.2 mole will be how much? So here also you will be go with the same method, x equals to 32 into 0.2. So this is another variation of it for calculating the mass. Okay, so this was the first part A. Let us go for the second question, second part of the question, that is you have to calculate the mass of one atom of aluminium. Let us check out this, the second part of the question. Second part is one atom of aluminium. Now as whenever I start this chapter, every time I emphasize on that periodic table, learning the atomic number and the mass number, because here also for aluminium, those who are not aware that the mass of aluminium is 27 grams or 27 U, again you will be not able to solve the question, right? Sometimes in the books, in the questions in your exams, the masses are given, but it is based upon that some schools they give, some schools they do not give. So better you should start learning this molecular mass of the atoms at least from atomic number 1 to 30. Fine. So here you need to calculate mass of one atom of aluminium, right? So we know that atomic mass of one aluminium atom is what? 27 U, right? So molar mass will be 27 grams. Okay, this is your what? Molar mass or gram molecular mass. Okay, 27 grams, right? Now we know that in 1 mole, how many atoms are there? 6.022 into 10 to the power 23. So this many atoms is weighing how many grams? 27 grams. And what is asked here? One atom mass will be what? So x. Yes, so what if it will become? X equals to 27 by 6.022 into 10 to the power 23. Can you see that? So the value comes as to be 4.48 into 10 to the power minus 23 grams. Okay, so this is again the unitary method. I am just doing all the questions in the two ways, so that if child is not able to remember the formula, so at least you have this unitary method where you can solve the through the concept, right? Is it clear to everyone? Yes, so this is also one of the method where you can solve the question. Fine. Let us see the third part of the question. Just a minute. Yeah. And sorry, this is like unitary method which I said to you, है ना? With the formula method. Formula method also you can go with this. Formula method is what? You will go with that capital N upon capital N upon N0 equals to small m upon capital M. Again here you need to find out this small m, है ना? Molecular mass is known to you of aluminium atom. What you will write? Aluminium it is there, so similarly it will be your 27 U. Capital N is number of atom is your 1, है ना? And N0 value you will put the Avogadro's number 6.022 into 10 to the power 23, right? So just we can put the values. Let us see, like 1 upon 6.022 into 10 to the power 23 equals to small m upon capital M is your 27. So again you will get the same this thing only in this method also. Small m equals to 27 by 6.022 into 10 to the power 23. So this method is again, this is the formula method. Just a minute. Yeah, so this is the formula method which you can see, the second step, and this one is again the first method, that is basically without the use of formula, the unitary method. Yes, fine. Now there is a third part of the question also. Just a minute, let me just check. Yeah, 2.5 mole of NaCl. This is the third part of the question. Let us see that. Third one is 2.5 mole of NaCl. Now NaCl, when we say, just the difference is this is an ionic compound. Ionic compound. Ionic compound means in which the ions are present, like this is the positive part, cation, and this is the negative part, Cl minus is the anion. So here also you need to calculate what mass you need to find out. Yes, what you need to find out? You need to find out the mass. So small m is question mark to you. What is given? Given is n equals to 2.5 moles. Na? Small n value is given to you, 2.5 moles. So here what you can do? Again you can go with the same formula which we discussed in this earlier one. Okay, in terms of mole is given to you, so you need to find out the mass. So small n equals to small m upon capital M, right? So 2.5 is given to you, mass you need to find out. Molecular mass, just a single difference is there. Whenever we consider ions, so rather than using molecular mass term, rather than using this molecular mass term, we use the term as formula unit mass. Just the variation is that, nothing else. In the books you will find out that for ions we consider the formula unit mass, right? So for ion, in spite of using this word molecular mass, you use the term what? Formula unit mass. So you will just find out the mass of this NaCl. For this again there is a use of periodic table. Mass of sodium atom, basically mass of sodium atom is your 23, right? And this one for chlorine atom it is 35.5. okay, this masses you can learn from periodic table. Okay, 23 plus 35.5. Is it clear? So here you can see that what it will be equals to 58.5. Yes, so you simply put it here 58.5. so small m is equals to 2.5 into 58.5. so the answers come to be as 146.25 grams, sorry. So just it is as simple as that, nothing complicate. By listening the word mole we just complicate our mind that it is too tough to understand. But to solve the mole questions for class 9, there are only just 3 formulas which you have to revise and practice more, so the things will be clear to you, right? Let us go for this question. Next question. Piece of copper weighs 0.635. How many atoms of copper does it contains? Yeah, so this is the next question. How many atoms? So again in this question what is asked? Number is asked. What is asked you should write, and what is given to you. What is given to you? Mass is given to you, 0.635 grams, right? So what you can do again here, you have been asked the number and mass is given to you. Okay, sorry, number we will represent it by capital N, small n is representing your mole, no? So it is very important to remember the denotions, otherwise you get confused. So capital N you need to find out number and mass is given to you. So we have that relationship of both the units. So which formula we can use here? Capital N upon N0 equals to small m upon capital M. Can we use this? Yeah. So capital N you need to find out. N0 6.022 into 10 to the power 23. Mass is given to you 0.635. Now again copper mass from periodic table it is 63.5. Okay, so here you will put it as 63.5. okay, so here if you will do this, solve this, so it will come as to be, see simply if you will first to make your calculation easier, you can just divide this value 635 both the values are same, so here it will be 0.01, right? So n upon 6.022 into 10 to the power 23 equals to 0.01. Capital N equals to 0.01 into 6.022 into 10 to the power 23. So what will be your answer? Just see, you can see 1 by 100, so just you will get the value to be as 6.022 into 10 to the power 21. This is as simple, nothing complex is there. Again here also you can go with that unitary method, but I am not discussing for every question, otherwise you will get confused. Simply we are using the formulas, just you need to make a proper identification that what is been asked and what you have to calculate. Okay, let us go for the next question. Yeah, this is something not the mole concept but the molecular mass concept, which is also most of the time it is asked in the exams. So you need to practice this also, like calculate the molecular mass of C12H22O11. C12H22O11, simply mass of carbon atom into 12. So one single atom mass of carbon atom is 12, okay, plus mass of single hydrogen atom is 1. So there are 22 atoms, so 22 into 1 plus 11 into mass of single oxygen atom is 16. So you just calculate this, 12 into 12, it will become your 144 plus 22 plus 11 into 16, it will be your 176. So overall if you will calculate this, it will come to be as 342 U. So this is mass of what? C12H22O11. If you will see the second one, CO2, just now we have seen mass of carbon atom is 12 plus 2 into mass of oxygen that is 2 into 16. So here 12 plus 32, that will be equals to 44. Let us see for the next one, NH3, mass of single atom of nitrogen is 14, right, and plus 3 into 1. So it will be 14 plus 3 and it will be 17 U. Because this we are talking molecular mass, so everywhere you will write the unit to be as U. I hope this is clear to every one of you, right? So this is one of the question apart from the mole concept, but this has also been asked in most of the exams, right? This is also an important part of the chapter. Next question, let us see. Now this is again I said I won't repeat the question, all the varieties of the mole concepts which has been asked, that I will be discussing it. So here you can see it again, that here it is asked, it is a sort of different question apart from rather directly asking that what number of moles or mass. Okay, here it is asking that two things are given to you, 11.5 gram of sodium and 15 gram of calcium, and you are asked that which has more number of atoms. You are supposed to tell that which has more number of atoms. So how you can calculate? Simply you can calculate the number of capital N for both the things, and you can tell that which has more number of the atoms. That is a one way, right? So we know that what that capital N is equals to small m upon capital M. Yeah, sorry, just a minute, moles. Yeah, yes, small n equals to small m upon capital M. Similarly for this also you can find out first the moles, है ना, moles you can find out, small n equals to small m upon capital M. Now we know that 1 mole is equals to 6.022 into 10 to the power 23, right? So whosoever moles is coming the highest, that will have obviously the more number of atoms, right? So let us calculate for this. What will be the value? Mass is given to 11.5, molar mass of sodium just now we discussed 23 it is. Try to memorize these things, okay? So it will come to be as 0.5 moles. Similarly here if you will calculate small n equals to small m value, how much it is given? 15 grams, and mass of calcium it is 40. Atomic number is 20 and mass is 40. So if you will calculate here, it will come to be as 0.375 moles. So you can see here this is 0.5 and this is 0.375. So which is having the lesser moles? This is having the lesser mole. So obviously with the lesser value, if you will multiply 6.022 into 10 to the power 23, so you will get the lesser number. So which among the following has more number of atoms? Answer is sodium. Okay, just don't get confused here by seeing that 11.5, though mass of the sodium atom is less, the value which is given is less, but sodium will have the more number of atoms. Why it will have more number of atoms? Because it has more moles. So obviously when you multiply this moles with the Avogadro number, you will get a greater value, right? So answer is sodium will contain the more number of atoms among both the things, right? Now this is one of the last question related to the mole concept. Second kind of the variety, next kind of the variety. Okay, let us see this question. Here you need to calculate the number of moles in 28 gram of helium and 46 gram of sodium, right? So 28 gram of helium, what you need to calculate? Moles. So here it is again very simple. mass upon your molecular mass. Yes, so small n, you can calculate, mass is given to you 28 grams, and what is the mass of helium? It is 4. So simple, it is 7. Okay, 7 moles. Secondly, second part of the question is about, again you will go with the same formula, small m upon capital M. So here it is 46 grams, mass is given to you 46, and mass of sodium atom is 23, right? So 46 by 23, it will come to be as 2 moles, right? So these all the different varieties of the questions I have discussed, which are supposed to be like asked from the mole concept. And there is one topic which is left out in this chapter, that is your atomicity, and how to find out the chemical formula. Atomicity and chemical formula, for that I'll make a separate video. This topic has been missed out. So in my upcoming video, I'll make content on this atomicity and chemical formula. I'll also share the link of the previous video in which I have explained about the mole concept, right? Okay, thank you so much.